You're listening to Let's Talk Sustainable Business.
Hello, my name is Uwe Schulte, and it's a pleasure to welcome you back to our second series of our podcast, Let's Talk Sustainable Business. The series is brought to you by the Conference Board Global Sustainability Center. Today I will be talking to Lars Kissau, Senior Vice President Global Strategic Business Development at BASF's Petrochemical Division. We will talk about possible answer to the plastic waste problem, chemical recycling. First, let me introduce our guest Lars Kissau to you. Lars joined BASF 18 years ago as marketing manager. He spent 7 years in Southeast Asia and China in different roles. And returning to Europe, he served 3 years as Senior Vice President Corporate Strategy and Sustainability. Now, as the SVP Strategic Business Development, he is driving the digitalization of the Petrochemical Division and is responsible for steering globally relevant strategy and marketing topics for that division. Lars achieved his PhD in organic chemistry at the Max Planck Institute for Molecular Physiology, my goodness, difficult to pronounce, in Germany. Welcome, Lars. Please tell us a little bit about yourself.
Well, thank you, Uwe. Thanks for the introduction. It's a pleasure to be here. I think you covered the key points of my CV already. What isn't in the CV, and I also didn't put that on LinkedIn, is really the passion behind or what's driving me, which is, I'd say, a passion to leave behind a better planet for future generations. So being a chemist by training, I'm very thankful that BASF has given me the opportunity, basically in every position, to do something in that direction. And that's also why I'm really excited to be here to talk about chemical recycling. I think this is a great topic and it motivates me and my team tremendously.
Yeah, but before we get started on that, I think we need to define what we mean by chemical recycling of plastic waste. From my perspective, it's a conversion of plastic waste through heat and pressure into the molecules that were originally the different plastics from the start. I guess you can explain this a little bit better for our audience, which has little chemistry background.
I think that sums it up quite well. Usually chemical recycling refers to technologies that break down long polymer chains of the plastics into their basic building blocks. This is really the main difference to mechanical recycling, in which the plastics keep their polymer structure as they are only cleaned, shredded, melted down, and reprocessed. The probably most commonly used chemical recycling technology is pyrolysis, in which the plastics are converted into pyrolysis oil by treating them at temperatures of 300 to 700 degrees in the absence of oxygen. And the oil that you get can be used as a feedstock for chemistry, basically as a replacement for many of the fossil feedstocks commonly used today. Another method of chemical recycling is called depolymerization. In this process, you take certain plastics, you break the polymers down into the monomers. For instance, if you look at a plastic polyamide called polycaprolactam, it can be broken down into the monomer caprolactam, cleaned up, and used again. This type of process only works for single material plastics. The pyrolysis really applies for all the materials.
So in essence, Lars, if you depolymerize, you really only break it down to the original constituent, but that only works for pure plastics, as you've just said. Pyrolysis goes a step further. It actually makes it basically into a fossil fuel oil again, but It's not fossil. It's caused by the chemical process of the plastic. Is that?
That's correct. That's correct. Yeah.
I hope that we've defined that enough. It's an emerging technology, and you guys at BASF have launched this as chem cycling. Mm-hmm. I wonder how did this evolve? Where did this whole idea start in your company, and how did you play a role in this?
So the first idea for this project came a couple of years ago when I was still in my role in the corporate strategy and sustainability unit. And there we really had at the start 2 trains of thought coming together. On the one hand, my team and I felt that BASF should, as everybody in the plastics value chain, contribute to solving the issue with plastic waste. I mean, if you look at globally, we have about 250 million tons of plastic waste produced every year, and only about 20% of that being recycled. and the other 200 million tons are landfilled, incinerated, or as a worst case scenario, end up in the environment. And so, as being a large producer of mostly durable engineering plastics, but still plastics, we felt that it's something of sort of being part of conducting your business responsibly to engage in addressing the issue of plastic waste.
Lars, sorry to interrupt. You just made a definition of durable plastics. Let's explain that because there are different types of plastic here. So the stuff as a consumer I know of is when I buy something, it's usually packaged somehow in plastic. So that's one-use plastic in essence. What you're talking about is more in my household. I have pipes in my house that are made of plastic, for example. Yeah.
Right. Pipes, window frames, insulation materials, structural components. These are things I would call durable because they, in some cases, after they're being produced, they stay in use for 50 plus years.
Sorry for interrupting, but I think it was important to make that discrimination. So.
Yeah, and I think that, as I was saying, the second train of thought that came to that was that if we want to meet the targets of the Paris Agreement and reduce CO2 emissions, we really have to shift the economy towards a more circular economy. We have to reduce CO2 emissions and we have to replace fossil feedstocks. And I think this was the second consideration, that aside from addressing the plastic waste issue, we saw an opportunity with ChemCycling to avoid burning plastic waste and producing CO2, and also to replace basically fossil fuels or fossil feedstocks for chemistry. So those were the two considerations at the starting point. The technology itself is not new. I think if you go back many years, pyrolysis has been around. There have been various attempts. And what we then early on said, well, this is not something that one company can do or should do. So you really talk about building an ecosystem. So we looked and working with partners on the technology side, bringing it from its currently very small scale. I mean, it's most of the pyrolysis plants are quite small compared to the industrial scale you have in the chemical industry. So scaling this up, developing the technology further. So that's one part of the ecosystem, and then of course immediately also working with customers to see that you get also the market acceptance. And we have involved customers from the very beginning in the project as well. And if you may have seen recently some announcements, some of the pilot projects we have done with on the say white goods, with Bosch, Siemens, Haushaltsgeräte, we had some cooperation as an example where you take C-cycled materials into an end user application. I think that was part of the project from the beginning to build this ecosystem and make sure this project actually progresses and gets scaled up.
Now, this project was conceived, if I got your CV right, at the time when you were Senior Vice President, Strategy and Sustainability. So how does that fit into the overall sustainability strategy? It is, as I can see it at the moment, still a minor component.
Yeah, I mean, volume-wise, yes, but I think if you go back in history, and I think this is a quite telling story for me. BASF was founded in 1865 by a guy named Friedrich Engelhorn, who was actually a goldsmith by training. And if you think about the work of the goldsmith, he learns from the start that any waste that he produces is worth gold. So he really sort of brought this into the DNA from the company, that you don't waste resources. You try to reuse whatever you have as byproducts, and you try to close loops wherever possible. So this sustainability thought has been in the company all along, and what we like to use a German word Verbund, which means integration. This Verbund concept for production is really based on this thought. So the thought of sustainably conducting business and saving resources isn't really new in the company. What is fairly new is basically when we announced this in December 2020 is the circular economy program that we've started, really trying to really move the whole industry from linear value chains to circular ones. And in this program, the chemical recycling plays a key role, where we really want to scale up the technology and get to a point where we can replace significant amounts of virgin feedstock with recycled feedstock.
That makes sense for me, but let's look into this a little bit more detail. there are several companies that have started looking into chemical recycling, and you see announcements left, right, and center.
Mhm.
Wouldn't it make sense that because it's such an important and crucial part of what we're trying to achieve here, to bring these different forces together and exploit the synergies?
Oh, absolutely. Actually, I would think it doesn't just make sense; it's a necessity. If you that the players in the value chain and many of the companies working on similar approaches join forces. Um, and let me give you an example. If I just look at some of the numbers, I have the 2018 numbers. Basically, in Europe, about 42% of the post-consumer plastic waste was recycled, and the ambition, the EU has a target of bringing that to 55%. So in volumes, that means we have to recycle another 2.3 million tons of plastic that today cannot be recycled. Um, so of course, mechanical recycling is well established, and there will be a certain part of the volume that definitely can and should be recycled mechanically. But if I only assume that half of this volume of this ambition in Europe requires a chemical recycling, then that's another 1.2, 1.1 million tons of plastic. And at the current scale, where a normal pyrolysis plant as it is built today is maybe around 10,000 tons, maybe slightly more. That would mean we have to build another 100 pyrolysis plants until 2030 to at least manage this target. And this is not something that one company can do. This is not. This also requires still a lot of technology development and hopefully also scale up to build larger plants. And that's why I think it's absolutely necessary that companies join forces and do this together.
No, I understand that. By the way, you just mentioned a shocking number. I think some members of our audience will be surprised to find that how little is actually being recycled in plastic. Um, the public has become more aware of this since we've seen the plastic floating in the oceans. Yeah, but it has been a problem that has been around for a long time, and I'm very glad that people are picking it up. And I think what we're dealing with here is the part of plastic waste that is more difficult to recycle. If I have a single stream of plastic, as we've discussed before, if I have PET, for example, and it's pure PET, that is a different thing. But in Germany, we have the famous yellow sack, and if we
Mhm.
put the star or the green dot, and if we put everything in there, soiled and everything, that is a bit different. I think that's what we're talking about here, isn't it?
Yes, but to be clear, I think a significant part of the volume of plastic waste today is mechanically recycled, and I think it should also be because it's well established. You mentioned the PET. I think that's a stream of waste where the recycling that is set up works very, very well. What we are really looking at with the chemical recycling are those streams, those materials that are difficult to recycle or currently not recycled. So I really see it as a complementary solution. It's something that we can add on to what we're already doing and to expand the overall volume of plastic waste that can be reused and simply avoid incineration.
Now, this sounds, like something that's worth pursuing, but there are critical voices are here, and we should
Mhm.
not ignore that. Let me ask you about this. So people say what you're doing, and we've just talked about a lot of degrees centigrade are necessary. So it's energy intensive.
Mhm.
The yield is relatively low, and in essence, it doesn't save any CO2 emissions. Um, why is it a route worth pursuing then?
I think it's those are valid questions, and to be honest, at the very start of the project, this is exactly what we asked ourselves too. Considering that you need all these temperatures, does this make sense? So and so if I look at where the process is now, again, I think it's still early stage. The technology can be developed further, but if we look at the facts, I mean, today, if you do pyrolysis of plastic waste, about 70% of the volume that you put in is recovered as pyrolysis oil. The rest usually is converted into a gas that is currently used to heat the process. I mean, you could also, in theory, depending on how you set it up, do further chemistry with the gas, but there's quite a good yield already. And again, this is on a small scale, and I think this will and can and will be increased. then we also looked at the CO2 emissions, and here it's important to look at the whole life cycle, and that's why we early on, and when we did this project, did a life cycle assessment. We had that carried out by a company called Fura, and we also, and the results that they produced, we had them vetted by external independent experts, because we wanted to make sure that it's a really rock solid comparison. And what this analysis really shows, that if you compare the chemical recycling of plastic waste to, let's say, alternatives such as incineration, your CO2 footprint is about 50% less. So in terms of preserving carbon for further chemical use as a structural material instead of burning it and emitting it as a CO2, there is a benefit, and this is what this life cycle assessment shows. And that's with these results, that's when we really said, okay, what we're doing makes sense. We're not, creating, we're not doing nonsense. This is really a good project, and it has a positive contribution to both the original aim to reduce CO2 emissions and the aim to recover carbon for further chemical use.
Yeah, and I think there is another aspect here, which in my mind is very important. So provided that you will work on the yield, provided that the energy balance is going to be more positive, and we are on a learning curve here, so I give you that. But the other aspect for me is that you are dealing with plastic waste that otherwise has only two possible ways. Either it's going to be dumped somewhere,
Mhm.
or it's going to be burned.
Correct.
So we cannot pretend that chemical recycling is competing with pure stream recycling of, as we said, PET, or, for example, scraps in the plastics industry, which are pure and can be recycled immediately, which we call, I think, primary recycling. So that's not what we're dealing with. We're looking at something. See, what really concerns me, I have seen all these, and you must have seen this in Asia as well, these dumps, wild dumps of waste in the countryside, which then leak
Yeah.
into rivers and basically end up in the ocean then, of course. And if that then becomes a valuable resource, then it's going to be interesting. But do you think we will be able to scale this to a point where in these parts of the world we can make this a viable solution?
Honestly, yes. I think we, first of all, we have to. I think, I mean, I love to travel, and I think this was one of the more shocking discoveries, that you can be in very beautiful countries and you turn a corner and all of a sudden you see a waste dump that shouldn't be there with lots of plastic, or you, like you said, you go swimming or you see the picture. So this is a problem that has to be solved. At the current stage of technology development, plants with about 10,000 tons or maybe 15,000 tons are fairly small. So it would be important to scale that, reduce the investment cost to bring this up. And I think what's also important, that it makes economic sense. I mean, all the companies that are looking into this will be looking to create a viable business model out of this. And I think that's what you mentioned. It doesn't make sense to recycle the, let's say, PET or the single product streams that have another use already. There is already an established business for that. That's not going to be a viable model to come in with chemical recycling. Those streams are going to be valued too high. So I think this is really where I see it's an additive solution. Some streams will be perfectly suitable for mechanical recycling, and other streams, I think, are the ones that we should attack with chemical recycling.
That's the recycling question, but let's face another challenge around here, and that is the real work we should be doing is completely redesign the value chains to avoid plastic and to reduce the use of plastic at least. Is that not the better way?
To a certain degree, yes. There's this. I'm sure you've seen this printed in many places. This reduce, reuse, recycle slogan, and I think that I like that. Obviously, globally, we are using way too much of the Earth's resources, so we need to reduce the use and be more resource efficient in any way. And obviously, if we look at single-use plastics and some of these actions taken globally, I mean, that makes perfect sense to reduce the use of materials in that sense. obviously, reusing materials, designing them for longer lifespan is important. Recycling can be part of the equation. I do think, though, that the plastic itself is not the problem. It's really how we deal with it. I think there are some applications or some benefits of plastic that really will be difficult to replace. I mean, it allows us to, let's say, make very lightweight packaging, build cars in a lighter way. Some of the food packaging made with plastic materials preserves food and avoids wastage or spoilage of food. And then here, if we try to do that without plastic materials and some of these high performance materials, we would incur other downsides that we don't want. So I think just sort of banning plastics, to be blunt, I think would be the wrong move, because you create a whole lot of other problems. Being more careful how to design products, and then closing the loops to reuse the materials, I think is really the target state that we should aim for.
I get that, but we should be very clear. I mean, plastic forks or straws made out of plastic are not necessary, and to avoid them is a straightforward thing. So we have gone overboard because it was cheap and straightforward to use. Let me come back. I mean, you've just mentioned something, the usefulness of plastic, and it's quite interesting. People want to get vaccinated at the moment, and I wonder where the materials that are being used. There are glass containers for the vaccine itself, but the rest of the process, of course, involves plastic. And the problem that arises, as far as I can tell, but you can rectify that for me, is that we have to actually put different things into plastic.
Mm-hmm.
And in order to make it the performance that's required. But that then in itself raises the question how to recycle it, because you have all these components in there which are unwanted, and in a pure mixed recycling would actually render the recycled material, if you just remelt it, less valuable. Is that correct?
Yeah.
Or
Well, I think maybe one example to consider in this respect is if you look at the multi-layer packaging. I mean, that I think we all know from the supermarket, if we buy packaged meat or packaged cheese, I mean, this is multi-layer packaging. This is not just a single layer of foil. This is many different layers of different materials. It's very lightweight. It protects the food from microbes, from oxygen, from moisture. So there's a lot of properties that can be built into such a material. And of course, it is not a single plastic material. So that when you come to the end of life, I think that's your point. That's then the recycling is more difficult. That's where I think chemical recycling would be a very good tool to recycle these materials, because replacing that, let's say, with a single plastic material. So if you substitute a multi-layer packaging material with a monolayer, you would have to increase the thickness significantly. So as a first step, you would create a lot more packaging by weight and volume. So you make the problem of waste actually worse in the first step, and the properties you might not be able to achieve. So I think here, this is for me one of the examples where we have actually very high performing materials, and we just need to make sure we close the loop. And I think that's where chemical recycling can be a viable solution.
But here I have to ask you, Lars, would you be able, in that process of creating that oil out of those mixed plastic materials, to get rid of all these additives and stuff that's in there which you don't want in the process afterwards? How is that possible?
This is how the pyrolysis plants are supposed to run and deliver. Basically, the pyrolysis oil that you want to take into a chemical plant has to meet a fairly narrow specification, because chemical plants generally are built to a certain specified raw material. So the task and what I mentioned before, the technology development that has to happen, is to further refine how the pyrolysis plants take plastics and the specification of the output. I think this is clearly a challenge. I mean, depending on how mixed it is and how soiled the material is, you can have a lot of impurities in the plastic that need to be removed before you can take the resulting pyrolysis oil and put it in a chemical plant for new production. And I think it's this purification that is already working to a certain degree. And I think this is also where we see a lot of technology development work still to be done to bring that to a further or higher level and more output.
But this is the unique positioning of this process, isn't it?
Right.
Having soiled and mixed plastic materials which nobody else can recycle easily, that would be the positioning for that
Right.
residual amount. Okay, I get it. Okay, now this puts it in an interesting perspective, because you guys, of course, produce plastics and resins, and therefore the question is, how does that fit into your business model? Just say a couple of words, because I think that merits another conversation, and we'll do that in the next podcast episode. I would love to talk further with you if you're willing, but just give us a quick glimpse of that.
Well, I think in terms of business, the engineering plastics, if I take that example that we sell today to many customers, those customers have a high interest to also over time have products that are not based on fossil fuels or have a certain recycled content. So basically taking plastic materials back and putting the pyrolysis oil made from recycled content into our production and producing new materials with recycled content. I think this is something that quite a number of customers ask for and increasingly asked for, and this is also what is driving us to push the upscaling of the process.
That triggers a number of questions in my mind, so we'll leave that to the next episode. Looking forward to that. Thank you so much, Lars, for sharing these insights with us. It's been very interesting. I've understood from you that there is a very special place for chemical recycling. It's not the holy grail. It's not replacing everything else. It is addressing the specific issues of very mixed and very, let me use the word, dirty plastic waste. That's where chemical recycling can come in. It's an early stage, but it seems to be promising if you guys spending your time and money on it. So looking forward to the next conversation. And to our audience, if you've enjoyed this podcast, then please remember to subscribe to our series and explore the entire catalog of podcast programming from the conference board by visiting the website at tcb.org/podcast. You can also write to us at sustainability@tcb.org. And thank you for listening. And please join us again in 2 weeks. And goodbye for now.
That was Let's Talk Sustainable Business.